And now we are ready to transfer to the computer. Let's connect the USB-C cable and continue with the software that comes with the scanner, Starvision. As you can see, I'm using the latest available version, which is 1.2.1-17. You will see this screen, which consists of workspaces, and you can immediately create a new workspace. Why is this? Because, as you can see on the left side, it is divided into 3 sections: workspaces, model library, and model viewing selection. This last one allows only viewing and choosing scanned models that have been imported into Starvision. Here, you find the connection to the scanner, which I've already done, and I've imported what was in the scanner here. This means I can now view my models in the model library. Continuing with what I was saying, you cannot do much in the model library mode. You always must create a workspace. It is mandatory. Another feature here at the bottom is the Shinning 3D Digital Cloud, which allows you to upload finalized models as a backup. However, this process is not automatic and must be explicitly requested. Let's create a workspace. New, delete the default name and call it Test. Returning to the main page and now to the model library, let's select the model we just scanned. Note that I have other models here, but this one was the last. It's worth noting that this model is 1.6 gigabytes. Additionally, some icons indicate and reference the modes used to scan this object. In this menu, you can view the model as a point cloud, as you see, and as the mesh created by the scanner. There is also an option to view the mesh, which is grouped with the model in one document, making the file quite large. I'll import it into the workspace we just created. Let's wait while the new workspace with this 3D model is prepared. Now, what can we analyze in the workspace? Note that you can select either the point cloud or mesh mode. This last mode only works if you created the mesh on the scanner. Otherwise, you would only have the point cloud available, which is the approach I typically take as it suits my application of the scanner. Below, you'll find information about both the point cloud and mesh. If you click here, you can see the texture, but since we didn't scan the texture, it cannot be activated. Here you can reset the view. Next, there's the cube tool for aligning the piece in a specific orientation. However, this tool may not be helpful because the object is entirely misaligned. The Starvision software, unlike the software for the other scanner from this brand, has some limitations. Currently, functions like object alignment are unavailable and may never be included. For alignment, I plan to use Autodesk Fusion to reorient the object there. Let's explore the tools to understand what is possible with this application. This software allows for one-click processing, commonly called wizard, and manual mesh generation, replicating what happens on the scanner. There's the cropping tool called clipping on the scanner, which is a nomenclature inconsistency as they perform the same function. The alignment command is only available for the point cloud. As the name suggests, it aligns different scans of the same object taken at different times or orientations. For example, if you scan the top and then the bottom, hidden during the first scan, 2 separate documents are created. With this command, you can merge the 2 scans, though only 2 at a time. This can be done automatically or manually. In tests, automatic alignment succeeded only once with this software. Manual alignment with Starvision works well if there are common points between the scans, allowing the 2 models to be aligned and merged. Finally, there's export. In mesh mode, there are slightly different tools, such as mesh editing options, cropping, measurement tools, exporting, and a cloud sharing tool. As a scanner user, you have 5 GB of space on the Shinning 3D cloud, enough for 3 to 4 models of this size. Returning to the point cloud, I'd like to show a detail about the workflow, specifically point cloud processing to remove excess points. Notice that the model has an isolated portion separate from the main domain. I left this intentionally in the scanner to process here. There's another area attached to the model, so in this case we effectively have 2 domains, the main object and another island, physically separated. This concept is important when using the cropping or clipping tools. Selecting a portion of the main domain with the lasso tool, I instruct the software to link all points within this domain. The software connects the points, leaving separated portions unaffected. If there were multiple such portions, you could select the main domain, expand the selection, invert it, and delete the unwanted islands. After cleaning up the points, finalize with Finish. The cloud is now clean and ready for mesh generation. Click Generate Mesh, and with a computer having over 32 GB of RAM, you can achieve a resolution limit of 0.1 mm. Initially, I'll disable mesh smoothing for comparison purposes. Though 0.1 mm may be excessive, I'll start with the recommended value of 0.14 mm. Previewing the process will take some time depending on the resolution and model size. With smoothing disabled, noticeable surface roughness and the orange peel effect are evident. Adjusting the parameters requires clicking Reset. Let's reapply smoothing with the same resolution, and the result is visibly improved. Once the mesh is complete, you can simplify it. For instance, a model with approximately 1.1 million triangles can be reduced by 50% without losing significant detail, making it easier to manipulate. Additionally, smoothing can be applied directly to the mesh. Tools like fill holes close gaps in the object, and their intensity can be adjusted. The cropping tool allows you to trim parts of the mesh. Using the polygonal selection, you can precisely select and delete specific areas. The last thing I'll do is a measurement. As happens on the portable device, this bounding box will appear, showing the object's volume, but that's not what I want. What I want is to measure a specific distance from this point to its symmetrical point. And the value I have is 102.0 millimeters. This slightly deviates from the value previously measured with the caliper, and incidentally on the portable unit. However, I recall that the mesh was altered. Let's take another measurement in this section, which was roughly where the caliper's jaws were touching, and we have 101 millimeters. I can't see clearly with this dark background. Yes, it's 101.8 millimeters, again a deviation larger than expected. The other dimension, giving a larger value of 116.7 millimeters, is the geodesic measurement, which considers all the contours from one point to another. This measure is not particularly relevant in this case. By the way, we also have the area measurement here. Obviously, I must select a polygon, in other words, a closed area. Once again, this was just to demonstrate the possibility, but in this case, it's not particularly useful. However, there are situations where this makes more sense, for example, to determine the amount of paint required to cover a panel that needs painting. Let's remove the selection and close the tool. With that done, you now have two options. Either export to your computer or to the cloud. If you're planning to continue working on this in Autodesk Fusion, export it to the computer. You can use OBJ or STL formats. Ply doesn't seem to be something Fusion can natively open, as it's a point cloud, but I'm pretty sure I've seen a plugin somewhere that allows this operation. However, the OBJ format as well as STL are guaranteed to open in Fusion. In the case of OBJ, it includes a bit more information, like the texture applied to the model. Since we don't have texture, I'll use STL. I'll export and save, and the process is complete. If you wish to upload it to the cloud, to the Shining 3D cloud, the name will be the one displayed here on this tree on the left side. That's why it's always a good idea to name your models. In this case, I'll rename it. Let's go ahead and share it. Now I'll send it to this space. But it's possible to create other areas. After the upload, a link and a QR code will be generated. These can be shared to download the file. I'll copy it to the clipboard. Regarding Starvision, besides the tool that lets you merge different captures, that's about it. If you go back to the home screen, you'll find a new workspace with this document inside. Let's take a look at the command that lets us align and merge two scans of the same piece. I'll use these two files I made earlier. It's a case for glasses that was scanned in different positions. And we'll attempt to align and merge them. The alignment, where we have this piece on one side and the piece in another position on the other side. This last one is quite messy, but I'll proceed. Maybe it'll work better than in previous attempts. I'll try auto alignment, maybe this time it'll work. Interesting. It worked. I'll add it to the list of models, and the result of the alignment is this. Let's close this. Now I'll generate the mesh with recommended values. Smooth off, this off, and finally click on preview. And here's the piece almost complete. Clicking finish. Now, in this situation, I'll do a cropping. Select the piece, select the domain, invert the domain, and finally delete. And we have the final piece, which turned out quite well. Except for these holes, which we can close. Let's accept, generate the mesh again. And now we can close the holes. But before that, I'll apply some smoothing to the mesh using the minimum value preview. It's expected that the orange peel effect will disappear. However, some detail from this element here may have been lost. Let's check. Preview again. Here, we need to reset. Preview again. Yes, we might lose some detail from this element. I'll try again. But this time paying attention to this area. Indeed, it's almost the same. We can still see it. Now, I'll close the holes in the mesh. Preview. And now the holes are closed. Apply. And we have our model ready for export. I'll export it in STL, as mentioned before, and save the alignment result. I'll open the printer application, in this case, Bamboo Studio. Though it could also be Prusa Slicer, these are the two programs I use and like. Let's start a new project and load the merged and closed model I just created. The piece was successfully loaded, which is always a win. I'll adjust the piece to position it for one of the possible printing orientations, perhaps like this. Now I'll add some support structures. And then just click Print Plate to start the print. In a few minutes, we'll have a replica of this piece. Interestingly, every time I do this, I'm amazed at the progress these slicing applications have made. So, my congratulations to the open source community who are the driving force behind the development of these tools. Thank you. Next step, Autodesk Fusion.